Okay, so in a prior video, we were looking at how to calculate our regression equation and our correlation values in Excel. And so now what we want to do is we want to go on and do a little bit more advanced analysis. We want to talk about how do we make predictions using our regression equation and calculating residuals. So I'm going to take the data that I had previously used and I'm going to copy it into a new sheet so that I have a nice clean sheet to work from. We previously had calculated that our slope was 1.38278 and our intercept was 11.83433. Now, what we're going to do in order to make a calculation is we're going to use this information in order to generate what the Y values are that are being predicted from that relationship. So I'm going to calculate here a new column, predicted Y values. So these are the predicted amounts based on our regression equation and our input X values. So I'm actually going to use the slopes that we got from the previous calculation. So I'm going to use this slope so that it will actually cover the entire range of values. Oops. I want this one times this guy. Now, one thing that I'm going to want to do in my formula is I'm going to want to fix this particular location. I want the X values to update, but I don't want the Y values to update. And then plus my intercept. And again, I'm going to want that to stay fixed. And now if I hit enter, this is going to calculate my predicted Y values. And again, just to see that formula again, it's going back to my other sheet to pull out the slope. It's going back to this sheet that I'm on to pull out the age. And then it's going back to my other sheet to pull out the slope. Now, you certainly can just put them all on one sheet. That's totally fine. But what I want to be able to then do is I want to be able to copy that formula down the column. And I'm just going to verify the slope and the intercept stayed in the same place, and all that changed was the age. Now, of course, I don't need this many decimal places to display, so I'm going to use my display to reduce them to the same number of digits that my original data was in. Now, I've only changed the display. I haven't actually rounded them. So rounding is another option, but this way they're only displaying 2 decimal places. They still include all of the other decimal places. And again, I could have used a hard-coded value if I'd wanted, just typed in the 1.38, whatever. But this also works. Now, the predicted values, again, those are basically, if we go back to our previous sheet, those are basically the points that are being plotted along this line. They are going to be very similar to the original data, but they will not be identical to the original data because they have no error in it, basically. They were looking at the trend. We're calculating the trend from the data, estimating it really. But then we're making our predictions based on that trend line. So these values will appear directly on that trend line. And if we wanted to, we could see how this works by plotting all of them together. And let's see if Excel is going to cooperate, and it does. So the predicted Y values are all on this perfectly straight line, and they are basically going right through the middle of the amount spent data, which has still the error in it. And so we'll just label this chart predicted versus true. Okay, now those are the predictions. So essentially all we've done is we've taken for our prediction, we're going to take the slope value that we calculated from our regression equation, our regression analysis. We're going to multiply it by the age. If we have another age, it's not it. As long as it's in this range of values, even if it's not a specific value in the data set, then we can still just plug it in with the slope and the intercept, and it will create a prediction. So again, as long as it's in the range, we don't want to go too far outside the range of the data. That's extrapolation, and that makes all kinds of assumptions about whether the trend is continuing or not, which may or may not be the case. Now, once we have the predicted values, then we can actually calculate the residuals. The residuals are basically just the difference between the original value and the predicted values, or vice versa. When we calculate the error on them, we're going to square them all, so we don't really care about the direction so much. So these are our residuals. And then what we can get from this data is that we can get the size of our error. So essentially, the residual error is the standard deviation for the residuals. So we're essentially our monitorings, or how far off of our predictions are we? And then if I calculate the standard deviation dot S, because it's a sample, then we get, in this case, around 3. What we would expect for the mean of the residuals is that they are about 0. Oops. And notice that E negative 14, remember that's very small. That's 13 zeros after the decimal point before you get to the -1 point, -169. So very, very small. This is essentially 0. This is a rounding error. And that's, again, that's part of the theory of linear regression, is that the residuals have a mean of 0, but then a standard deviation that depends on the error. And so that's what we found here. Now, we actually got this residual error in our previous calculation when we used the data analysis tool pack. The residual error is right here. It's called the standard error. Those are the same thing. So that is another tool that comes out of that data analysis tool pack that you can calculate manually or not. Now, once you have the residuals, you can use them to determine whether or not there is any pattern to the residuals, because you want them to be really random. And so what you do is you create a residual plot. Now, the residual plot, you can calculate, typically it's plotted as X versus the residual. In this case, age versus our residuals. It's basically just a scatter plot. And what you want to see in your residual plot is that there is no correlation. There's basically noise, there's no trend, and that there's no pattern to the behavior. There's no sort of curvature. There's no spreading out of the variances as the data changes as you go across the graph. You want this to look noisy and random like this. Now, sometimes people will plot the original values, the original Y values against the residuals. It depends on the data that you're graphing, but in either case, what you really want to see, and we'll label this residuals versus X and residuals versus the Y. In both cases, what you do want to see is you want to see that the residual plot is random, that there's no relationship in this data. You could, if you want to, try to plot a trend line on it. And what you would want is that the slope to be basically horizontal. I'm going to go ahead and show you. This is not a very strong slope. Now, sometimes you will get a little bit of a slope, just random chance, but it should be very small. Same thing in this one, if we were to plot a trend line on it. This one is much better with X versus the residuals. This is obviously a horizontal line at 0, which is what you want. Again, sometimes with the Y values, they won't come out as completely random, but they should still look basically random. And that's what we see in both of these cases. Now, in the data analysis tool pack, you can get these residual plots and the residual calculations calculated for you for free. And so I will just show you how that works. We go back to regression, and I'm going to use the same values that we used before. This is basically the same data, just on a different sheet. But what I'm going to check is I'm going to check residuals and residual plots. I'm going to check one additional graph down here, which we don't talk about very often, but this is another way of looking at our residual data to see if it makes sense to us. And it plotted over here. And I'm going to move my Y residuals a little bit out of the way. Oh, come on. There we go. And I didn't move my data over quite enough. So let's see. All right. Now, if you check those additional boxes, you get some additional things. So out here, you get your observation. This is from your list of X values that they're just numbered, the row numbers. You get the predicted amount. This is the same as the column that we calculated over here, our predicted Y values. That's this value right here. So notice the first value is 67.76, and this is 65.76, sorry, 65.76. They're both the same value. Again, this one still shows all the decimal places. And then the residual is the Y value that we originally started with minus the residual. And I did it in the same order, which is good. And then it lists, again, the residuals. It's calculating, it's displaying all the decimal places that I wasn't displaying, which is fine. And then that's this whole data set right here. Now, these calculations are for the normal probability plot. Now, what's going on here, I will just briefly summarize, is it is sorting the residuals, and it is internally, and it is converting them to percentiles, because there is a particular behavior that we expect to see when we plot the percentile versus the amount versus the values. Because what we expect to see is if the errors are normally distributed, the residuals are normally distributed, when you plot them against the percentiles, that they will basically form a straight line. So that's actually, both of these calculations will show up anytime you check on one or both of these graphs. So the residual calculations will show up anytime you check on the residual plot. And these two sets of calculations will show up when you click on the normal probability plot. Now, both of these graphs will appear very small when they originally show up. So I'm going to just make them a little bit bigger so we can see them a little bit more easily. And again, this is the same residual plot that we had just previously calculated. That's this one. It's the data analysis toolpath will always produce the residuals versus the X input values. And when we do multiple regression, if there's multiple X inputs, then you will get multiple residual plots, one plot with each X against the residuals. And you're always looking for the same thing. You want it to be random and no trend. For the normal probability plot, you basically want a straight line. It's never going to be a perfectly straight line, but the idea here is, again, that you would be able to put all of the percentiles in order on an approximately straight line. If you have a little bit of wiggle room out at the end, then that's fine. But generally, you want these to follow more or less a straight line. And this does pretty good job following that line. So this is one way of just checking the normality. Normally, if you look at the residual plot and you see that randomness, that's usually good enough. Okay, so data analysis tool pack. It gave us all of this great information about the coefficients, but it also calculates the residuals and allows us to do some diagnostic tests like the residual test without having to do the calculations ourselves by hand.